So what Alif does, like you say, we do microcontrollers, we do fusion processors. We are in this space where we provide silicon solutions that have integrated capability to also do machine learning alongside the standard type of system applications.
Hello IPXers, we're joined today by Henrik from Alif Semiconductor. Now, we've been talking a lot about AI at CES. Everybody's got their own definition, everybody's got their way of describing it, and everybody's got their way that they think they're doing it. And for me, I found the whole AI discussion very, very confusing. So I thought I'd ask Henrik the first question of, what is your definition of AI, Henrik?
Oh, that depends a little bit. Sometimes you wake up in the morning and the definition of AI is a huge cyborg from outer space pursuing you relentlessly. But I think really the kind of common definition these days is that AI is essentially when you're able to ask a machine a question that you have not given it the answer to previously, and it's able to figure out something that seems like it could be an answer to that question.
Very interesting. So when we've been talking to people, it comes across that it's almost like it's a data set. They have a definition for that data set is the data that comes in, which has been mainly camera at CES, has been, that's what we've been looking for, it recognises it, and then it gives feedback and says, I found that. Going by you, that's not AI.
Well, it kind of could be, but there's different things, right? You can do AI on vision in the way that you describe, but this can also be applied to things like voice or sounds or movement of fluids through pipes or electric current going through circuit boards and things like that.
Yeah, we've heard the same thing. I just use the image and vision just as one of the definitions that we've been talking about at CES.
Exactly.
Okay.
But it's essentially that when you design a system, that you need to be able to tell the difference between a number of different things. And that number of things is so vast that it's impossible for you to put all of that into the kind of sequential logical order that you usually do when you develop an application.
Yep.
You know, if red, then go here, if blue, then go there.
Yep.
No, but if it's a license plate...
That's just a system.
That's just a system, exactly. But when it has to take real-world data into account all the time, there is no way that you can put in all those parameters. So what you do is you just try to collect the data set that the computer can learn to figure out kind of roughly how to determine what is going on its own.
Right. So,
hence the term artificial, right?
Yeah. So in your definition, then there absolutely has to be machine learning in there that is constant, that is real time. Correct.
Essentially, you start by providing a set of data that you can train a machine learning model on. But the idea is also that as the system is deployed, you can figure out which corner cases where the system might not have produced the correct response. And then you can add that back in the pool, stir the pot, add some more intelligence into the system and make it smarter over time.
Right. So if we come back to what you do at Alif with your 32-bit microprocessors, if our engineers are looking to understand what you do, you're going to be able to say to them, we're going to offer you machine learning, which will learn as it goes along and give you answers that you wouldn't necessarily have known you'd have got at the beginning.
Correct. So what Alif does, like you say, we do microcontrollers, we do fusion processors. We are in this space where we provide silicon solutions that have integrated capability to also do machine learning alongside the standard type of system applications. Because the way that we kind of see development of embedded system going, now that machine learning tools have become advanced enough that you can actually create robust industrial strength solution using these type of machine learning models, then people want to put that next to the existing systems that they are already designing using traditional methods to make them better and to make it possible for them to solve problems that they haven't really been able to get at before with the, if I dare call it, old tools that they had available.
Yeah. So we're not really allowed to use the word unique, but would you say that I'm about to use the word unique.
He said it, I didn't.
Would you say that approach to what we now call AI in your 32-bit microcontroller arena is unique? I said it.
Yeah, did it. And thank you for that. I would say that it's unique for right now in this particular point in time, right? So with electronics and things like that, you can't really, I don't know if you've ever been able to say that you're the only one that has a certain solution, but we definitely have quite a head start on the competition with designing products that do this level of integration, that enable users to get access to the type of machine learning performance, the type of I'm blanking on the word. You have to edit this out.
It's okay, because I do that all the time.
Yeah, the type of power efficiency is the word that I was looking for, that we can provide with our solutions. So we can kind of not just in an academical sense show that it's possible to do this on a microcontroller. We can show that it's possible to do very efficiently, very cost effective, and very low power.
Okay, so let's just move on to low power. Before we do that, so let's just finish off. Definition of AI for Alif is you do bring in data, you do have a data set, but your definition is that your microcontroller has to learn while it's moving along to give you information to improve your system.
Ideally, yes, that is exactly the thing that will make this future-proof.
Right. So when we've been talking about AI, which we've been doing all over the last 2 days, the use of power, obviously every time you get that machine to do something, it's burning just a little bit more power.
It's very compute intensive.
Yeah.
If you look at what actually goes on in a system that is trying to, through artificial intelligence, figure out if what it's looking at is a cat or a dog, that's a lot of math that is going on.
Yeah.
And on any type of controller, a lot of math means that you're running that core at its peak performance during the entire period that it's trying to figure out the answer.
Nearly all the time.
Yeah. So if it takes you 5 seconds every time you ask it a question, that's 5 seconds that you're running at 100% CPU utilization. That drains battery, right? So you want it to finish that as soon as possible.
Right.
Not just because you want low latency in getting the answer back, but because you want to be able to put it in a low power mode so that battery can last for a month instead of a day.
Right. So now you obviously solve that in software.
Well, in a combination of software and hardware, I would like to say.
And hardware.
Yeah.
Okay. So how does the low power bit work? Because obviously that's absolutely key. You know, in everything. You know, if we've been when we've been wandering around CES, AI has come up everywhere. Nobody really wants to talk about how much data it's burning up, and then everybody's talking about low power. Mm-hmm. So just give us a brief summary about your approach to low power while using AI.
On a very high level, we have designed a system architecture that we base our devices on that combine one domain that is designed purely for efficient compute. So it's not super fast, but it can do things at very low power cost. And you can use that to kind of sense what is going on around a device by collecting sensor input and looking at that data. You can use artificial intelligence to kind of sense is there movement or not movement. But then when you want to find out, oh, there is movement, I wonder what caused it. Then we have other systems in our devices that are much more high performance that can be woken up super fast and that can figure out exactly what happened in a fraction of the time that it would have taken that high efficiency system to do it. But then they go back to sleep, so they don't contribute to the overall power consumption.
Right. So it is an overall architecture approach that Alif have to do both AI, so the machine is learning all the time, but being very efficient with its power.
Correct.
At the same time. Okay, so we have our definition of AI from Alif Semiconductor, which we think is very different from everything else that we've heard from CES in the last 2 days. Henrik, thank you.
Thank you, Guy. It's a pleasure.
So, that was Guy's first chat with Alif at CES 2024 with our good friend Henrik. We've got more videos coming which have demos of this technology, but yeah, it was very interesting to hear another take on what AI really means, because it is the buzzword at the moment. In the meantime, while we prepare those other videos, check out Alif's Ensemble devices on the ipxchange website by following the link